All right, so the second part of the video is going to be looking at the position form of a vector. So to begin with, if we have a vector that has an initial point at the origin at 0, 0, and a terminal point somewhere else other than the origin, then we say that that is a vector that's in standard position. And we usually notate that by AB with these, almost looks like an inequality, but it just has those brackets like that. Looks like a less than or greater than. That's a standard way to represent a vector. There's other ways as well. All right, so if a vector is not in standard position, then its initial point is not at the origin. And then to change that vector with its initial point and terminal point, then you can apply this simple formula where you just subtract the x components and subtract the y components of those 2 points on a plane. So this kind of works like this. This diagram shows this vector CD is not in standard form. So you want to write down these points so I can kind of show you where this comes from. So basically the first point, the initial point, is x1, y1. The terminating point is x2, y2. So what I want to remind you of, as I said, you can move a vector anywhere you want to on a plane as long as you don't change the magnitude and the direction. So in a sense, what you're doing on this is when you move this, you're just basically trying to find this component, this x component. So that's the difference between x2 and x1. That's what that part is. You end up just getting a triangle that kind of goes like this. Okay, this part right here, that part would just be x2 minus x1, and then this part would be the difference between the y values. So this part right here would just be y2 minus y1, and then you can just move that vector to the origin 0, 0. So what you do is you just do this. You just take, if this is your initial point, x1, y1, and x2, y2, then this gives you the first component, and then that gives you the second component like that. Okay, that's the idea. So this is just showing you how you would convert a non-standard position vector to a position vector, which just means it starts at the point 0, 0. And if you look at that diagram, the magnitude didn't change. I mean, it's still still looks like you're going over and up the same amount. So those vectors are the same. Okay, so we're going to do some position vector work here. So we're going to, given the initial point and terminating point of the vector, we're going to write each vector in standard position. And then we're going to give what we call the component form, and we're going to graph the original vector and the position vector, and I'll show you kind of how we want to do this now. Okay, so the other thing I was going to mention on this is we have the component form is usually written as AI plus BJ. I is the horizontal part, J is the vertical part, like that. Okay, and I'll show you in this next page how that goes. Okay, so let's go ahead and start these examples. Let's go ahead and begin by plotting this out. So if we go to the point 2, 3, that would be our point A. And then we go to the point 5, 6, that would be our point B. So our vector on this would just be the directed ray from A to B. So that would be the direction. The first point is the initial. The second one is assumed to be the final, like that. So the way you put this in standard form is basically like this. Okay, what you do is you calculate like this. You just take the x components. So you do 5 minus 2 in that order. And then you do 6 minus 3 in that order. Whoops, why is this thing screwing up like that? Okay, I have no idea why it's doing that. Let me do that again. So 5 minus 2, and then we would do 6 minus 3. Okay, so we would get the standard form of this vector. We can write this then. There's 2 ways you can write this. You can write it as, this would be 3, 3. So that would give you one way to write that vector. And then we're going to go ahead and we're going to graph this. So the other way to write this is in the component form. We would just say 3i plus 3j. Okay, these two things mean the same thing. All right, so what we'd end up doing then is we want to graph this vector. We would start at the origin, then we would go over 3, up 3, like that, and then that would give us a picture of that standard component form of that vector. And notice on this what happened is you can tell that the direction is the same and the magnitude's the same. So if you notice on this vector is going 1, 2, 3 to the right, and it's going 1, 2, 3 up. Well, that's kind of what this is saying right here, see? Okay, so you just slide that over, then you've got that in the standard and component form then, okay? All right, the next one, let's go ahead and do this one. Okay, so let's start by plotting these 2 points. So we have the point negative 4, 1 is your point A. Your point B is over 2 down 5. That'll be the terminating point of that vector. And then we'll go ahead and connect this from A to B like that. Okay, or like I tried to do. Okay, all right, so let me try that again. All right, let's go like that. There's my vector like that. Okay, now our goal is just to slide that A to the origin and slide the B the same route like this. I'm going to show you really how this works. If you just do this, you would slide this 1, 2, 3, 4 to the right. And then it would go, once you slide it 1, 2, 3, 4 to the right, then you would be moving down 1. And then that's where that vector would begin. So that vector just begins there. So you actually just do the same thing to point B. You just go 1, 2, 3, 4 to the right, down 1. And then that's how you can draw that. You can do it without the formula by doing that if you want to. But the formula is real easy to just crunch out like that. So that would be your final vector that's in standard form. Okay, so this is basically what we do. We just subtract the x's. So I like to write it like this. I just do 2 subtract negative 4, comma, and then subtract the y values, negative 5 minus 1. Be sure that you subtract them in the right order. It's the second point minus the first point. So anyway, that would give you 2 plus 4 is 6. Negative 5 minus 1 is negative 6. So I want you to notice, if you graphed this thing, you would be going over 6 down 6 to get to that terminating point. And then the component form of that vector, we write 6i and then minus 6j. Like that. So that would be the 2 ways to write that standard form of that vector. Component form, we usually use the ij form like that. Okay, so let's see. Let's go ahead and do these 2 problems. Make sure that everybody can do these okay. So go ahead and pause the video, and when you're ready to check, just check. Whoa, I don't think I gave you guys any points on this. I'll tell you what I forgot to do on this. I'm going to pause, and I think my points are like hidden by this graph or something. Let me pause and get this corrected for you. Okay, so work with these right here, these 2 problems. Okay, I fixed the handout. I just didn't have any points on it, so I fixed that. And go ahead and let's try these then. Okay, so here's what you should have had. On this problem number 1, your original point is 3, 4. Second point is 7, negative 2. So if you want to find the standard form, you just do 7 minus 3. And then negative 2 minus 4, so you should have got 4, negative 6 as your standard form of your vector. And in component form, you say 4i minus 6j. Those are both the same. They both mean exactly the same thing. Components just when we write I and j. And then the vector you should have drawn was just over 4 down 6, starting at the origin. Second problem, your original point was negative 1, 6. Second point, 4, negative 5. Again, you do 4, subtract negative 1, and negative 5 subtract 6. So you should have got 5, negative 11 as your standard form of your vector, or 5i minus 11j in the component form. And I just sort of estimated the graph doesn't go down to 11, so over 5, down 11, that would be how you would graph that. So what I want you to notice on this is you can tell those vectors are in the same going in the same direction, and they have the same magnitude or length, so visually it should look right to you. All right, so let's see. Let's go to the next page. And I'm going to do this and then close off the video. I'm going to try to do some kind of short pieces on these problems, short videos. Okay, so this one says determine if the two vectors are equal given the initial and terminal point. Well, really what you do is we have two vectors on this, and what we're going to do is just put these in component form. So this vector 1, what we're going to do is just do this. And let's just use this notation. So we're going to go 5 minus 2, comma, and then 1 minus negative 3. So that would give us the vector 3, 4, or 3i plus 4j. Okay, the second vector, in order for it to be equal, it's got to turn out to have the same standard form. So again, I'll just go like 9 minus 6, subtract the x components, and then subtract the y components, 3 minus negative 1. So that ends up giving 3, 4, or 3i plus 4j, so therefore those two vectors are equal. Okay, even though they start at different points and end at different points, they both have the same standard form, therefore they have the same magnitude and direction. Okay, so that's how you work this out. Okay, we'll do the same thing on this one. Vector 1, we're just going to go 3 minus 5, subtracting the horizontal components, and then subtract the y components. So that gives the vector negative 2, negative 3, which means that would be the vector negative 2i minus 3j. Okay, vector 2, do the same thing. You're going to do 9, subtract negative 1, and then negative 4, subtract 3. So that would give you the vector 10, negative 7. So that's different. So those are not equal. Okay, so if you look at kind of what I got there is, got that vector, they're different. Over here we got the same thing. So equal and not equal. Okay, so I'm going to go down the bottom of the page and let you go ahead and do these next two problems, and then that will close off the second part of the video. Okay, so go ahead and pause if you would. And okay, so this is what you should have come up with. Example 1, you want to make sure that when you did the standard form, you got the vector negative 3, 6, negative 3i plus 6j as a component form. And on vector 2, you got the same thing, so they're equal. You can look over the calculations I did. Okay. Second one, not equal. The first vector, you should have got negative 7, negative 3, negative 7i minus 3j. Second vector, should have got 10, negative 6. So therefore, those two vectors are not equal. Okay, so that'll wrap up the second part of this, where you're just looking at taking a vector and putting it in standard and component form and determining if two vectors are equal. Two vectors are only equal if they have the same magnitude and direction. So in this kind of example, they had to turn out to have the same component form. Okay, that'll wrap it up.